Hello every guys, can you hear me? So if okay, then we will start for now. Alright. Yes, hello every guys. Yeah, it's already 6:30 here, so I start. So for the first question is about what? It is about the calculation, right? We want to calculate 1, 2, 3, 4 and divide 1, 2, 3, 4 and 1, 2, 3, 4 over 1, 2, 3, 5 times 1, 2, 3, 6. It's what? First, we make this one into an improper fraction so that it will be easy for us to get the calculation here, right? So it is 1, 2, 3, 4 and this proper, we mix fraction, we make into the improper one, right? So it will be 1, 2, 3, 4 times 1, 2, 3, 5 plus 1, 2, 3, 4. Right, this is it. And over the denominator 1, 2, 3, 5. So we times 1, 2, 3, 6. Then the things will be like what? 1, 2, 3, 4 times, right? Denominator becomes the numerator. So 1, 2, 3, 5 on the up. And this one is 1, 2, 3, 4 times 1, 2, 3, 5 plus a 1 here, right? It's like this. And then we times 1, 2, 3, 6. So 1, 2, 3, 6, 1, 2, 3, 6, 1, 2, 3, 4, 1, 2, 3, 4. So it is 1, 2, 3, 5 here. Alright, so the answer here, 1, 2, 3, 5. Okay, now let's go to the second question. So, a line in a triangle is to this kind of things. So this one we have how many lines? One line, right? And this one we have 3 lines. So here, right, for this, we also have one line. But we want how many lines for this one? 3 lines. The same pattern here, right? So 1 line, 3 lines, 1 line, 3 lines. So among 301 to 305, which one has 3 lines? 301 here, right? So the answer here is A. Alright, each of them forming 120 degrees, which is also 120 degrees in the previous one. So that's why we choose it. Okay. So the third question, on a playground, 1 to 1 students lined up in a solid square formation. Okay, so 1 to 1 student and in a square formation. So it means what? This square, it is how many rows, how many columns? 1 to 1, we know it is 11 square, right? So it is 11 rows and 11 columns. So first, 1 row of students left. So 1 row left. So for the number in the row, we should look for the row or we should look for the columns here. So number of people in 1 row, it is the number of columns, right? So we should look on the column. So here, 1 row, it has how many columns? 11 columns. So of course, we have 11 students left. And then a column left. So for the column, how many students are there in the number of the columns? Are there in 1 column here? It is the number of rows here, right? We should look for the rows. So 1 column, there are how many students here? It means we have how many rows? So how many rows are being left? 11 row, and we already have 1 row being left. So only have 10 row. So it means 10 students left. So the answer here is easy, right? First, 11 students left. And second, 10 students left. So here, altogether, 21 students have left. Alright. Okay, the question 4. It's known that 7 bird blocks can be exchanged for 1 rabbit, 7 rabbit to 1 fox, 7 fox to 1 tiger. and age 70 bird. Okay, so we want to know how many tiger blocks remaining. So here, right, first we have age 70 bird blocks, right? So in order to get the tiger blocks, we need the fox, right? In order for the fox, we need the rabbit. For the rabbit, we need a bird. So first, we need to transfer the bird blocks into a rabbit block. So that's why we first divide it by 7. So after I divide 7, it is 1, 2, 4, remaining 2. It means what? It means we can exchange 1, 2, 4 rabbits block and 2 bird. So for the 2 bird block, can we exchange any more? No. So we just leave it here, right? How about the 1, 2, 4 rabbit block? The rabbit can also be changed into the fox, right? So we divide it by a 7 again. So 1, 2, 4, we divide 7, it is 17, remaining 5. Which means we have 17 fox and 5 rabbit being remaining. So we just leave the 5 rabbit and focus on the fox, right? So 17 fox, we can change for how many tiger blocks? 2, remaining 3. So we have 2 tiger blocks and 3 fox blocks. So in the end, we have how many tiger blocks? 2 tiger blocks, right? So we have 2 tiger blocks. The answer here is C. Alright, the 5th question. Oh, one round of a soccer tournament and winner got 2 points, loser get none. So here, in one match, we have a winner, right? We have a lose. So for the winner, yes, 2 points here. For the loser, 0 points. But how about the draw? For the draw, right, it is 1 point for each of the team when they get a tie. So for the draw, each of them gets a draw, and each of them get 1 point. So when you focus on the 2, 0 and 1, 1, do you find something in common? Yes, the total here, right? So for the total, winner get 2, loser get 0. Altogether they get 2 points. For the draw here, winner get 1, loser get not winner. For the draw here, each of them get 1 here. So the total is also 1 plus 1 equal to 2. So you can see, no matter who wins, no matter who loses, no matter whether they get a draw or not, right? The total of the points here is always the same. So the total number of points, it is always about, we calculate how many matches are there, right? So the total matches is how many? It is 6 teams and in a round robin system, right? So the first team, he have 5 games with another, right? For the second team, he cannot play with the first one because we have already make it once, right? So for other teams, and 3 and 2 and 1, right? Or you can make 6 teams, we just choose out 2 and we find the combinations here. It is also another way to determine the matches, right? So it is 62, 62, the same, right? So the total match is 15, so we know this one is 15 here. So the total points, it is each match, we know we have 2 points in total. So we have 15 match, we have 30 points. And now it is asking the 6 team get how many points? And we know the 5 teams get 7, 6, 5, 4, 3, right? So it is easy. We just use the total minus 1, 2, 3, 4, 5 team score, so we get a 6 team score, right? 30 minus 7, minus 6, minus 5, minus 4, minus 3. So it's like 30 minus 25. So we have 5 points. Yeah? So we have 5 points here. Alright. So any questions for these 5 questions here? Any problems here? Alright, so here let's continue. So let's go back to the paper here and the sixth question. So we have a bucket of water. First remove 2/5, second remove 3/4, and remaining 3 liters. So this is like the branching method, right? Because we see remaining and something after remaining, right? So you use the branching method. So first 2/5 removed. So how many remained? 3/5 remained. And then 3/4 removed. So who remained? 1/4 remained. So we know this is 3 liters. So we can build the equation, right? So the total, and first 3/5 remain, and based on it, 1/4 remaining here, and it is 3, right? So the 9/20 of the total, not 9/20, 3/20 of the total is 3 liters, right? So the total here is 3 divided by 3/20. Not 30, 3/20. So we know the total is 20. Yes? You know the branching method, and it's super easy, right? You just build the relationship here. Alright, and this one, we have a little novel here. But it is easy, I promise, it is easy. It's about the fraction here. So we have a tombstone of a Greek mathematician, Theophanes, and 1/6 of his life is blah blah blah. So of the life, do we know the life? We don't know the life, right? So we just build the something as x here, right? We said life is x years. So 1/6 of his life, it is 1/6x, right? And then he gets 1/12 of the life here. So 1/12x. And he get married and remain childless, okay, so 1/7x. And after 5 years, it means plus 5, after 5 years, plus 5, right? He had a son, and the son, so sad, only half of the length of his father's, so 1/2x, which is the son's age. And then, yes, he lived for 4 more years in sorrow and end his life here. So we know this is different parts in his life, right? But when we combine them together, it will be what? If we combine them together, it will be the life of the Greek mathematician, right? So it will be the x here. So if we add them up, it will be 84, right? This is 14, this is 7 plus 12 plus 42, x. Plus a 9, right? Plus a 9. So it will be x. So the answer here is, right, you just calculate it is 75/84. So you move it to the right. 9 will be equal to 9/84x. So here x will be 9 divided by 9/84. So the answer here is 84/4x. Yes, so the Greek mathematician is 84 years old. Alright, this one. Distribute 10 gifts among 3 children, ensuring each child receives at least 1 present. So how many ways? Okay, so first, this kind of question is a permutation and combination, right? We want to know how many ways. So just assume which way will work. We give an example like here, right? So we have 10 identical gifts. So we just write down 10 gifts here. And how can we distribute it like this? How can we distribute the gifts to the children here? So first, I just assume I give 4 gifts to 1 children, right? 4 gifts for the first children, and second one 4, third one 2. This is kind of combination, right? This is for child 1. This is for child 2. This is for child 3. So based on it, can you find something interesting? So one way, it is linked to how we just make them into parts, right? The method of the inserting planes here is the way of distribute the gifts. So what does it mean? It means how we put the 2 plates here. 1, 2. The situation, it will equal to the ways, right? now we know how many different situations for us to insert the planes. You just think about the vacancy, right? You just think about the vacancy. So at least one gift, right? At least one gift should be given. It means what? It means only these vacancies will be selected, right? Only these will be selected, and each vacancy between the gifts can only have one plate. Or somebody don't give any gifts, they will receive 0 gifts, he will cry for it, right? So it is this meaning here. So altogether we have how many vacancies between the gifts? We have 10 gifts minus 1. 9 gifts here, 9 vacancies here, right? 9 vacancies here, and we need to choose how many plates here. So in order to make them into 3 parts, we need 2 division here, right? 3 minus 1. So this is how many situations, and we know it is 9C2. Do you still remember the formula of 9C2? Yes, 9 times 8 divided by 2 times 1. So it is 36. Yeah, it is 36. So B here should be the correct answer. Alright, B here is the correct answer. Okay, this, fraction calculation. M divided by 3 minus N divided by 8 is 1 over 24. Yeah, so we don't know M and N each one of the value, but we can just have the 2 equations here, right? So why not we just simplify the equation? So we know M over 3 minus N over 8 is 1 over 24. So we make the denominator being the same, right? 24, and this one is 8M, this one is 3N. So we know 8M over 3N over 24, it is 1 over 24. So we know 8M minus 3N, it is 1, right? And then we know what? We know M plus N is 7. So it is easy, right? It is easy. We just build an equation here. M plus N is 7. So we want to know the M. We set as equation 1, we set as equation 2, right? We want M here, we don't want the N inside it, so we just cross out the N here. How can we cross out the N? Yeah, minus 3N and plus N. So plus N with times 3 is plus 3N, and we add the minus 3N, the N will go away, right? So it is the second equation. We times the 3 and plus the 1 here. It will be like 8M minus 3N plus 3 times M plus N, and it will be the right, 1 plus 7 times 3. So if you open it, it will be 8M plus 3M equal to 22. 11M is 22. M here is 2. So M here is 2. Yeah, none of the above is correct. So for this question, we choose E. M equal to 2 here. Alright, the 10th question, is about something about the logic. So I think this question is the hardest inside the MCQ questions. The only challenging one should be like this. Okay, so Tom's family went to a movie. Wow. And they're setting a row from left to right. Good time. And Tom arranged everybody's seats and found, they have so many criteria. First, both Dad and Tom are not adjacent to Mom. So based on it, we cannot get where they seated. Right. So both Dad and Tom not adjacent to Grandma also count. Both Mom and Tom are not adjacent to Grandpa. We also don't know how they seated. But for the fourth criteria, right? Grandma is to the right of the grandpa and next to him. So based on it, we know how they are seated. A part of it, right? We know a part of it. So based on the 4 here, we know grandma is sitting next to the grandpa and at the right. So grandpa, if it is here, right? Grandma should be at the right here, right? After we know, we can go back, right? So grandma, we have grandpa at the side of it. So how about the other side? Who should be on the right of the grandma? Right. So let's go to the grandma part. Right. So we go to the 2. Right. Both dad and mom are not adjacent to grandma. Right. So here there are 2 cases. So both Dad and Tom not adjacent to Grandma. So who are remaining? Mom, Dad, Tom. 3 persons, right? Mom, Dad, Tom are remaining, and Dad, Tom not adjacent. So only Mom can adjacent to Grandma, right? But there are 2 cases. The first case is yes, Mom is at the right. Grandpa, Grandma, and Mom. This is the first case. How about the second case? Just think about if the Grandma is on the most right seat. Yeah, nobody will have it, right? Nobody will sit next to Grandma. This is also another case, right? So it means Grandpa, Grandma, and nobody sit beside it. There are 2 cases. And then we have known who is sitting on the right of Grandma, right? But who is sitting on the left of Grandpa? This is another case, right? So we can go from the third case. So both Mom and Tom are not adjacent to Grandpa. So it means what? Both Mom, Tom, not adjacent to Grandpa. So also we have 3 people remaining: Dad, Mom, Tom. Mom, Tom not adjacent to Grandpa, so only Dad can be on the left of the Grandpa, right? So we also have 3 cases. First case, Dad, Grandpa, Grandma, and Mom. Right. Second case, the Grandpa is at the leftmost, right? So nothing beside the Grandpa, except for Grandma. Nothing here. And Grandpa, as Grandpa is on the leftmost, right? Grandma and Mom. And the third case is from where? It's also here, right? So we have Dad, Grandpa, Grandma, and nothing to the right. There are 3 cases. And then we verify from the first, right? So for the first case, right? For the first case, what is it? Both Dad and Tom are not adjacent to Mom, right? So here, what should be the Tom in the first case? So Tom not adjacent to Mom, so Tom cannot be here, right? Tom can only be here. How about the second one? Both Dad and Tom not adjacent to Mom. So for the people here, no matter who is him, Tom or Dad, they will always next to Mom. So this part, not possible. How about this one? Both Dad and Tom not adjacent to Mom. So if here we have Mom and Tom being here, right? So Dad should not be adjacent to Mom. So Tom should be here, right? But how about the Mom? Mom can only be on the leftmost, and she will be adjacent to Tom. Also can't be the case, right? So we know it is Tom, Dad, Grandpa, Grandma, and Mom. So who is in the middle? Grandpa is in the middle, right? So D here is the correct answer. Alright, so this is it. Okay, so now let's go to the section B. So we have dog wolf and pig oink working together to build a house. Yes, it is a chicken rabbit problem, right? It's super easy. So first, we just assume, right? We just assume the dog, not dog. We are asking the dog wolf. So we just assume pig oink do all the work. So they transport 10 times in total. If pig oink does all the work here, how many bricks will be transferred? 1 time 45 bricks and 10 times in total. Yes, we have 450 bricks being delivered. And then we need to substitute 1 pig transport to 1 dog transport. So how many bricks less will be transferred? So 1 pig, 45 bricks. 1 dog, 20 bricks. So yes, if we transfer 1 pig to 1 dog, we have 25 bricks less. And then we can know how many times did the dog move transferred, right? 1 substitution, 25 less. And in total, we need to have how many less? 450 minus 300, because we know they move in total so 300 bricks, right? So 450 minus 300 is a total less. And each substitution, 25 less. So it is 150, and we have 625 here, right? So we know the dog transferred 6 times. Yeah, the dog transferred 6 times. Or you can use the algebra to solve it, but yeah, due to the time, we just give you one method. Right. You also can use the algebra. It's also okay. Alright, this one is about the angle calculation. So ABC equal to ACB, DAC equal to ADC. Okay, so this angle equal to this angle. This angle equal to this angle. And we know BAD is 21. So we want to know the angle of ABC here. Good. So how can we do it? So if we want to know the angle of ABC, yeah, we can also start from something we have known in the geometry, right? So when you find the relationship between ADC and ABC, you can find something interesting. So ADC, you know it will be the 21 degrees plus the angle ABC. Why? Because the exterior angle theorem. Right, the exterior angle theorem. The ADC is exterior angle, and it should be the sum of the other 2 interior angles, which is 21 and ABC. And then we know ADC, it will be equal to DAC here. So this one, DAC will also be equal to 21 plus ABC. Alright, and then we know the angle ADC, we know the angle DAC. How can we make use of it? Yes, we also know ABC equal to ACB. So if we use these 2 angles combined with C, yes, they are the 3 interior angles inside a triangle. So what is the sum? The sum of the 3 interior angles inside a triangle is always 180. So we know ADC plus DAC plus angle ACB, it will be equal to 180 here. Right, it will be equal to 180. And ADC, yes, 21 plus angle ABC. And DAC, the same, right? 21 degrees plus angle ABC. And ACB, of course, we know it is just ABC here. So total here, 180. So if you make it simplified, it will be like 3 times angle ABC plus 42 degrees will be equal to 180 degrees. So angle ABC is super easy, right? 180 degrees minus 42 degrees and divide by 3. So angle ABC will be 46 degrees. Yeah, 46 degrees. Alright. Okay, question 13. Yeah, it is a kind of average problem. So Mr. Tan left and a 25-year-old teacher get into it. So it is like we substitute or we replace a 60-year-old teacher into a 25-year-old. Right, it will be like this. And the average reduce by how many? First reduce 4 and then reduce 7. Yes, the average will reduce 7 years. So we can see, yes, the decrease in 1 should be the total decrease in average. Right. So based on it, we can know how many people are there. Right. So 60 minus 25, this is one type of the decrease. Right. Everybody's still the same, but the total decrease by 35. Right. It will be equal to, you just imagine, everybody's average decrease by 7 years. So yes, we can know it is the number of people, yeah, the number of people we times 7. Every people decrease 7 years. It will be the same, right? So the people here will be 60. It will be 35 divided by 7, right? So 5. Okay, so we know if we have Mr. Tan or if we have the 25-year-old teacher, there will be 5 teachers in total. So we can build a model, right? So just assume this is the average. So this is Mr. Tan's age, and we know he is 60 years old. And it will be like everybody in the average and plus a 4. Right, the decrease 4. So everybody's age minus 4. Or we can just write it as the difference between this new average and old average, it is 4. So beside Mr. Tan, we also have 5 minus 1, 4 teachers. Right. So what is the total age less than the average? 4 times 4 equal to 16. Right. So we know the number of the ages for the other 4 is 16 less than this original average line. And where to compensate this 16 years old? Yes, they are from the Mr. Tan. So this is 16 years old, right? This should be the same. So we know as Mr. Tan is only one person, right? So this part is also 16. So the line here is 60 minus 16, so 44. And 4 years old less, so it is 44 minus 4 equal to 40. And then, yes, a 25-year-old come. So this is the new average, the current one, right? So somebody come, so the age decrease again, and we know he is 25 years old, right? And the age between this average, it is also 3. So we know the current is 40 minus 3, right? 37. So we know the answer is 37. Or you can just verify it, right? So still, besides this 25-year-old teacher, we also have 4 teachers in total, and each of them is 3 higher. So total we have 12 years old higher. And we need another 12 years old to compensate it, right? So where should it be? Only being here, right? From the 25-year-old teacher. And you know it will be 12 here. So 37 minus 12, also 25. Yeah, it works. So we know the 37 is the correct answer here. Alright. Question 14. Owen and Chris board. Okay, this is also easy. So it is about to use the algebra to solve the equation, to solve the question, right? So first, we set the pen $X. Then we know how many money Owen has, right? Owen is short of $2.30. So Owen's dollar, it is X minus $2.3. How about Chris? He is short of $1.90, so X minus 1.9, right? So if they combine them together, it is Owen's money plus Chris' money, so X minus 2.3 plus X minus 1.9, right? These two are the total of their money. And then he buy a pen and $3.80 left. Yes, the total is X plus $3.8. So you can solve the equation here, right? 2x minus 4.2 will be x plus 3.8. So x here is 8. So we know 1 pen, $8. Right, this is it. 1 pen, $8. Alright, this question. Yeah, the number puzzle, but I think it is super easy. So we know A, B, C, D, they plus together it is 22. And yes, it is A, B, 9 in the sum. So here, first we will find, there is a 9 here, right? So what will give a 9? So B plus D can equal to 9. So or it can be equal to 19. But is the 19 being possible? And it will give a 9 in the sum. So the maximum of B and D, they can both take 9, right? 9 plus 9 is 18. The maximum can only be 18. So how can they get 19 here? They cannot. Right? They cannot get 19 here. So of course 19 is not possible. So we know B plus D is 9. And we know A, B, C, D plus together is 22. So we know A plus C, it will be 22. 22 22, we minus a 9, right? Total 22. We minus B minus D, so we minus a 9. So it will be 13. So B plus D is 9. So there's no carryover here, right? So AB is just A plus C. So it is 13. So we know this is 1, this is 3. So we have A plus B is 1 plus 3 being 4 here. A plus B, 4 here. Alright, this number puzzle, I think it is easy. Yeah, it is easy. So any questions for the first half of our today's paper? Yeah, do you have any questions? Are all answers in TASMO whole numbers? Yes, there will always be whole numbers because in MMOS there will be whole numbers. And normally it will not be larger than larger than 10,000. Yeah, the largest will be 4-digit number. Yeah, any questions here? Alright, if no, then continue. If no, then continue. So let's get back to the question 16 here. Alright, AB is a 2-digit number and satisfies the following properties. So first, AB differ by 1. And then, okay, we have so many AB. So we skip it, right? There are exactly 4 positive perfect square numbers smaller than 20. Than AB. Yeah, this point is important, right? Because we know from this 2 here, 4 square is smaller than the number AB. But AB is smaller than 5 square, right? AB is smaller than 5 square. So we know the range of AB. It is 16, smaller than AB, and 25, larger than AB. And then we can get it from the 1 here. So the 2 digits of AB differ by 1. So A here can either be 1, so B here 1, 2 or 1, 0. No, not in the range. Or A here be 2. So if A here is 2, yes, AB can become 21 or 23. So which one is correct? We need the 3 here, the third condition. From 3 we know AB is not a prime number. So 23 we know is a prime. And 21 is composite. So not a prime. So 23 go away. Yeah, AB 21. Easy, right? Easy. Okay, question 17. Yes, it is something about the area here. Right, so we know we have a shaded region in a rectangle, and we know the not shaded. We have a total region in a rectangle, and the shaded here is 98. So what is the length of A? So it is something like total minus part, right? It is like this kind of things. So here, yes, we know A, or we don't know A, but we know the length for the missing rectangle, right? The length here, total is 14, and we have 3 in left, 4 in right. So in middle here, it is 14 minus 3 minus 4. We'll have 7 cm. So we know the missing part is 7 cm. So the total is, yes, the missing rectangle plus the shaded part. Right. Total length 14. Breadth 9. It will be equal to shaded. And the missing rectangle, length 7, breadth 8 here. And we know the shaded is 98, right? So 1, 2, 6 will be equal to 98 plus 7a. So 7a here is 28. A here is 4. Right, this one is super easy. Once you know the total equals to several parts adding up together, right, you will get the answer. It is also about the calculation. Alright, question 18. Yes. Question 18 is something like the inclusion and exclusion problem. So we have 100 foreign tourists visiting Singapore. And yeah, 70 understand Chinese, 52 understand English, and 10 people do not know anything. Okay. So we are asking how many people who only know the English but not Chinese. So for this kind of inclusion and exclusion problem, right, we have a tool to help us. What is it? It is a Venn diagram, right? So you just draw the Venn diagram first. So in total, we know we have 100 tourists in total, yeah? And some of them speak Chinese, some of them speak English. So for Chinese and English, we have two sets here. And we know 70 understand Chinese. Right, I use another color here. Okay, I erase it. Okay, 70 is here, and we have 52 here. Right, and then we know, yes, 10 people do not know either of it. So here, in order to get who only understand English but not Chinese, so which part is it in our diagram? Yes, this moon shape, right? This moon shape should be something we want to know. So we know the total is 52, and we want the moon shape. It is we need to get the leaf shape here, right? We need to know who know both of it. How many people know both of the language? And we use 52 to minus it, right? So based on it, can we get how many people are still how many people can speak both of the language? Yes, we can. Right. First, we can know how many people speak at least one language. It is a total 100 minus those who know nothing. Right. So 10 here. We have 10 stupid guy here. So 90. Right. We have 90 tourists. Yes, has speak at least one language. And then we can know who speak two language, the super smart guy. So for those who speak two language, it is, yes, we know the whole part is 90. So it is 70 plus 52, and we minus the whole part. So it is like the overlapping part added twice, right? So if we minus it once, the remaining will be once. So it is 70 plus 52. This is one in left moon shape, one in right moon shape, and the middle overlapping part added twice. So we minus everything once, we get the middle one. So it will be 122 minus 90, so we have 32 tourists. Yes, we have 32 tourists speaking two languages. So who only understand English but not Chinese? Yes, it is just those who speak English, so we have 52, minus those who speak both, 32 here. So the answer here is 20 tourists. Yes, we have 20 people who understand English but not Chinese. Alright, question 19. Okay, Dr. Dragon. Yeah, we have a dragon. So he go to work. Yeah, at 8 o'clock he departs and 6 minutes late. So next time he leave, he buy a bicycle and riding it. Alright. So this is also kind of journey problem, but yeah, we have two different situations. So if it is hard, then why not try the calculation? Why not try the algebra and do the calculation here? Right. So we just set. It is x minutes. We just said it's x minutes. Scheduled for work starting from 8 a.m. So just imagine, yeah, the deadline for he starts work is sometime, and the total duration between 8 and this time is x minutes. So we can know the total distance here, right? So he starts at 8 o'clock and he will be late for 6 minutes late. So it is how many times he is traveling? X plus 6 minutes in total, right? He traveled for x plus 6 minutes, and we know the total speed is 50. So we know the distance, right? Total time times the speed. total distance. X plus 6 plus 50 times 50. Right. So in the second day, yes, he starts at 8:20. So it means the total time left, yeah, it is already being minus 20 minutes. Right. He has wasted 20 minutes here. Like having the breakfast, I don't know. So X minus 20 is remaining, and he ride a bike, arrived 2 minutes early. Yeah, it's super fast, right? 2 minutes early, it means 2 more minutes he is not traveling. He is already there, right? The dragon is already there. So it is the total time for the traveling in the second time. And we know the speed for the dragon riding a bike, it is 100 meters per minute. So this is another expression for the total distance, right? And we know they are the same. The distance is always the same, right? The school will not move. So we can just solve this equation. 50x plus 300 will be equal to 100x minus 2200. So 50x is 2500. X here is 50. So yeah, we know he will need to just arrive at the school at 8:50 here, right? So the distance, you just take one of it. The left part I just for example, right? So 50 plus 6, this is the total time. He will travel for 56 minutes in the speed of 50 meters per minute. So it is 56 times 50, 2800 meters, right? The answer here is 2800. Yeah, just like this. Okay, the 20th question. The teacher asked Jack to choose 2 paintings of different types from Chinese paintings, oil paintings, and watercolor paintings. Okay, so among 3 types, we need to choose our 2. So we need to discuss the cases, right? We have a lot of cases choosing 2 out of the 3. So for the cases here, I can choose one Chinese paintings, right? And 1 oil paintings, right? Or I can choose 1 oil paintings, 1 Chinese, 1 oil. It could be the case, right? Or I can choose 1 Chinese, 1 watercolor. Or I can choose 1 oil, 1 watercolor. Just like this, right? 1 oil, 1 watercolor. Yeah, no U here. But can I choose 1 Chinese and another Chinese painting? Can I? Yes, 2 different types. So this case won't happen. Right? I cannot choose 2 same paintings here. So Chinese plus Chinese, it will not be possible. So another question here. Right? Are they happening on the same time? Can I choose 1 Chinese, 1 oil, and then I choose 1 Chinese, 1 watercolor? No. Among these 3 cases, I can only choose 1 of them. Right. So here, it is the OR relation. We just use plus. Right. We just use plus. So for the Chinese and oil painting, we have how many different combinations? We choose first 1 of the 5 Chinese paintings. So it is 5 here. It's 5 here. And oil painting, 3 choices. So I choose 1 Chinese and 1 oil painting, right? I choose it at the same time. Right. 1 Chinese and 1 oil. So it is the AND relation. We use the multiply. 5 times 3, 15. Chinese plus watercolor, it is 5 Chinese, right? 5 Chinese and 1 watercolor. So 5 times 1, 5. Oil plus watercolor, oil we have 3 paintings, watercolor we have 1 paintings. So 3. So the answer is just we add these cases up, right? So 15 plus 5 plus another 3, so it will be 23. Yeah, we have 23 options. Alright, so this is it. Okay, any questions for section A and section B here? Oh, okay, so yeah, then I just continue here. If no questions, then I continue. So the section C, yeah, section C for this paper is not that hard. So the short answer question first is about the counting 2D shapes. So we have different ways, right? We have adding line method or we have counting by categories. But in this question, yes, counting by categories is the most easier one, is the easiest way. So we just count by categories, right? We just said every side is 1, right? The small side is 1. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Right? Every side is 1. So first, we have the 1 times 1 square. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, we have 12 1 times 1 squares. And how about the 2 times 2 squares? We just focus on one midpoint, right? It will be like this. 1, 2, 3, 4, 5. Right, we have 5. And is it all? For this, we always have the common squares. But how about the tilted ones? We also have the diagonal lines here, right? Do they form a square here? We need to think about it. Right. So if we think about the tilted squares, do we have 1? Yes, we do have 1 in the middle here, right? The middle one, this blue one, it is a tilted square, but it's also a square, right? So we have another one. So this is a lot of students will miss, right? So we know the total answer, right? The final answer, it is just 12 for the 1 times 1 square, 5 for the 2 times 2 square, and the last tilted in the middle. So it is 18. Yeah, we have 18 squares here. Alright. Okay, this question. This is about the ratio problem, although you can see that the figure is something like the geometry. But it is a ratio problem, I promise. So here we have the shape A, shape B, and shape C. And yes, overlapped region B is 3 over 16. Okay, so we know we have part A, part B, part C. Right. So for the pentagon, right, it is 3 over 16. So 3 is what? 3 is a part B here. Right, 16 is what? 16 is the total. The total of the pentagon is just combined by A and B. Right. So we know A plus B is 16. So how about A here? 16 minus 3, right? The total minus B's part. Yeah. So we know it is 13 to 3 for A and B. And this is for pentagon. How about the rectangle? How about the rectangle here? For rectangle, we know B to the rectangle here, it is 2 to 9. Yes, B here is 2. And 9, it is the total part, which is B plus C here. But we know B plus C is 9. So, yes, the C here is just the total minus B's part. So 9 minus 2 will be 7 here. So we know A to B is 13 to 3, B to C is 2 to 7. So do we know the A to B to C? Yes, we just make the B become one number here, right? So 2 and 3, we just take the LCM, least common multiple of it. Yes, 6. So we make B become the 6. So this is 21, this is 26. So we know A to B to C is 26 to 6 to 21. A to C is 26 to 21, which is M to N, right? M to N. So M over N is just 26 over 21. Is it in the lowest terms? Yes, because 26, 21, they are co-prime. Right? There's no common factor, or the only common factor between them is 1. Right? We only have 1 as a common factor between 21 and 26. So co-prime, it is already in the simplest form. So this is the final answer. M plus N is 26 plus 21 will give you 47. Yeah, so the answer here, 47, should be the correct one. Alright. Okay, so now 23, yeah, we have another geometry question, but it's about the cutting of the shapes, right? So we know the area of the square ABCD is 32, okay, good. And all other points are midpoints, so they are located like this. Alright, so we need to know the shaded part. Yes, first, if all these things are the midpoints, you will see, do we have some special model here? Yes, it is a half area model, right? Something we have learned. It is a half area model. So we can have the square 1, we have the square 2. Right? For the square 1, we know it is a half of the area ABCD, which is half of 32. Right? A half of 32. So 16 cm squared. How about the square 2? Yes, it is a half of the square 1. So it is a half of 16, which is 8 cm squared. So now we know the square 2 is 8, but how can we get the shaded part? Yes, we can just cut the whole figure into several parts, right? We can just cut the whole figure into several parts. It is what we have just learned. So yes, we just cut by the midpoints here, right? Make full use of the midpoints. So we build a grid like this, and we know we have 3 blank triangles. The first triangle, we know it is 1/8 of the square 2. The second one is 1/4 of the square 2. The third one is 1/4 of the square 2. So we know the shaded. It is a total minus part, right? Total is the square 2. Minus 1/8 of the square 2 minus 1/4 and minus 1/4 of it. So it will be the total minus 1/8 minus 1/4. Yeah, 3/8 of the square 2. We know square 2 is 8 cm squared, so it is 3/8 times 8 will give you 3. Yeah, so the shaded part is 3 cm squared. This is it. Yeah, this is it. Okay, 24. Question 24 is something in a fairy tale, right? The tiger wants the forest animals to get a meeting here and 28 seats. Yes, a round table. Okay, 28 seats around a round table. So here, the little monkey taking a seat. And no matter which seat it chooses, always adjacent to an animal. So this is kind of a pigeonhole principle. Okay, so first, we want that at least how many seats must be occupied. So we need to think, right? We need to think about. Think about what? Think about using least animal and occupy most seats. What does it mean? It means we can make full use of the seats beside each animal. Right? For example, we have seats 1, 2, 3, 4, 5, 6, 7, 8. We have 8 seats. Right? This one we see the animal, this one we see the animal, this one we see the animal, and this one we see the animal. Right? So we have 5 vacancies, and no matter where the monkey sits, for example, this is a monkey. No matter where the monkey sits, they always have animals beside it, right? There's always adjacent to one animal, right? So this is the question I want to tell you. But is this the final answer? Is it the best one? So if you look at the sides, right? So yeah, for example, I use a blue color here. These 2 seats are adjacent to the first person, the first animal here, right? How about the second animal? Yeah, they have adjacency like this. And the third one here. Right. The fourth animal here. So you can see these 3 seats, they have overlapped vacancies, right? Which means we have a waste of seats. So why not? We just make the 2 animals sit a little bit further. So how about another distribution here? So for example, we always have 9 seats. So also we have 9 seeds here. So why not we fully use the 2 sides of one animal? For example, right, we have an animal sitting like here, and here are the vacancies. So for now, we just make one animal sitting a little bit right to this seat and to this seat. So here, it's also no matter where the monkey sits. For example, here, the right one has one animal already seated here, right? For I choose another one, right? The monkey seat here, also another animal seated beside it, right? This can also be the case, and we know it can work, right? It works. So now, based on this distribution, we need to find out at least how many seats must already be occupied by the animals. So it is about the cycle, right? Every animal has 2 seats beside it, so we have 3 seats a cycle. We have 3 seats a cycle here. So if we have 3 seats a cycle and we have 28 seats altogether, so it will be 28 divided by 3. Yes, we have 9 cycles, remaining 1 seat. So how about the remaining one here? We need to think from the end, right? For the end here, right, we have one animal here and another seat. And as it is a round, right, the end will be linked to the start. So also an animal here. So for this one, it is a remaining one. Right, it is a remaining one. Does this seat do need to have an animal here? So first, if we don't have an animal, if the monkey sit in this seat, right, this is a monkey. Yes, left side nobody, right side nobody, right? It won't be the case. So here, this one must be occupied by another animal. Then the monkey, yes, cannot sit here. Left or right, always we have one animal already seated. So it means this one we need to plus 1. So the final answer, it is just 9 cycles. Each cycle we have one animal here and we plus the 1 in this seat. So it is 9 plus 1 will be equal to 10. Yes, so at least 10 seats must be already occupied by the animals. Alright. So now question 25, Sam sells honey and the price is blah blah blah, and reduce the price, the sales get more. Yeah, so it is a maximum, yeah, the extreme value problem. Also something we have learned in previous class, right? So $100 per bottle and $1 reduction in price, 5 more additional bottles. So here, right, we just set reduce X dollars. Right. We just set reduce X dollars. So how about the sales? So the price for every bottle, it is 100 minus X. But how about the total number of bottles being sold? Yes, 300 plus 5X. And we need to get the maximum. So to this point, yes, you can just think about the same sum, but we need to get the maximum product. But then you will find one thing. The sum here is not a constant. You may say, Teacher Kevin, the sum is not a constant. How can we use the rule for the extreme value here? Alright, so why not we make it being constant? So here, right, we have a 5x, we have an x. So we know it is 5 times the x here and plus minus, right? So why not we just extract these 5 out? What does it mean? It is 100x, 100 minus x will remain the same, but we extract the 5 out, and it is 60 plus x. So at this time, we also want the maximum. So 5 times this thing, it will be like this part and this part. We time it together, it is the maximum, right? It's like this one being maximum. So this time, is the sum of it being this constant number here? Yeah, it is, right? The sum is 100 minus x plus 60 plus x. X cross out. 160 here. Right? We know the sum is constant and we want the maximum product. So here it is just the 100 minus x equal to 60 plus x equal to 160 divided by 2. Right? We make the difference become as small as possible. So the product will become as large as possible. Right? It will be 80. So 100 minus x is 80. X here is 20. Or you use 60 plus x equal to 80. X here is also 20. Right? So we reduce $20. So what is the price? The answer here is 100 minus x, right, equal to 80. So $80. Yes, $80 is the final answer. Alright. So here, question 26. Alright, finally we go to the last 5 questions. Okay, we have a cinema and giving the screenings per day from Monday through Friday on weekdays, right? And 6 screenings on per day on weekends. Yeah, it's kind of something of the calendar problem. And in the year 2025 from January to March. Okay, so there's one special thing here. From January to March, yes, we have a February. So the February, how many days are there in it? It will depend on the year, right? So the first question, from January to March, right? How many days? In February. So 2025, right? Divide by 4. It will be something remaining 1, right? Something remaining 1. So if we have remaining 1 here, it means 2025 is not divisible by 4. So it means the February we have 28 days. So now we know how many days are there in total, right? So January start from 30th. So we have 30, 31. 2 days here, but we have 2 days here. February we have 28 days. And March, from the 1st of the March to the 30th of the March, 30 days. So in total we have 60 days. So we can use 60 divided by 7 will be 8 remaining 4. What does it mean? What does it mean? 8 means 8 weeks and 4 means 4 more days. Right. And how about the 4 more days? We know the 30th of January is a Thursday. So it means we start from Thursday. So the 4 days are Thursday, Friday, Saturday, and Sunday. We have these 4 days. And after these 4 days, we have 8 weeks, right? We will have 8 weeks. So, yes, those in 4 days will happen in 9 times. And those who are not in these 4 days, they will only be in the 8 weeks. So they will appear in 8 times, right? So we can know. From Monday, we have 8 times. Tuesday, we have 8 Tuesday. Right? Wednesday, we have 8 Wednesday. Thursday, this time, yes, we have 1 Thursday in the 4 more days. So 8 plus 1, 9 days. Friday, 9 days. Saturday, 9 days. Sunday, 9 days. So then we know everything about this calendar problem, right? The only thing we need to know is to calculate how many different screenings are there in total. So you just use the formula, right? So 8 Mondays, 8 Tuesdays, 8 Wednesdays, 9 Thursday, 9 Friday. These are the weekdays. So altogether we have this kind of weekdays. Every weekday 3 screenings. And the weekend it is 9 Saturday, 9 Sunday. And each of them 6 screenings. Right, this is the final answer. It is just the 42 times 3 plus 19, not 19, 18 times 6. 18 times 6. So it will be 126 plus 108. 2, 3, 4. Right, 2, 3, 4. So we have 2, 3, 4 screenings. Right, 2, 3, 4 is the final answer. Alright, so this is how we do it. Okay, now we are going to the geometry problem. Yeah, this one is the hardest geometry problem in this kind of paper. Right, not in this kind of paper. In today's paper. Okay, So we know the square has a side length of 20. So 20, 20 here. And divided into 3 equal parts. So some of the division are linked and we want to know the shaded region. So we'll form a square here, right? We'll form a square here. But how can we know the area of this shaded region? We need to make use of the 4 trisection points, right? So for the trisection points, we know this part equal to this part equal to this part. And it is a square. We know this is 90 degrees. And this one cross angle 90. This one cross angle 90. And they are using the same angle. So for the 2 triangles in the blue shape, are they in a special relationship? For this triangle and this large triangle, are they in a special relationship? Yes, they are. Right? They are the similar triangles. So we can know the ratio between them, right? The ratio of the sides. So this is 1, this is 2 parts, right? Because of the trisection points. So we can know this side length to the side length of the square is also 1 to 2. So we can name it A here and 2A here. Right? We know it is a similar triangles. So 1 to 2, this 2 side 1 to 2. So A here, 2A here. And we can do it for all the 4 triangles, right? So we know this is A, 2A, A, 2A, 2A, and the A here. Right? After we know, and we can also make use of the square in the middle one. Because 90 degrees, so 90 degrees, 90 degrees, 90 degrees, right? And we know it is 90 degrees. Of course, we can know the total area, right? We know every area of the triangles. We know the middle of the square. So we can express it as a total, right? So the total, it is just 4 triangles plus the squares. Not squares, square, right? 4 triangle, we know the base and height because it is 90 degrees, right? So base here 3A and height here A divided by 2. This is how we calculate 1 triangle, and we have 4 triangles in total. And square here, we know side length is 2A, so 2A times 2A, right? So the answer here is 6A squared plus 4A squared is 10A squared, and we know it is 400. Why it is 400? Because we know the area of the square is 20, right? Another area. The side length of the square is 20, right? So the area 20 times 20. So we know 10A here is 400, A here, not A here, A squared here is 40, right? 10A squared, 400, A squared, 40. So do we need to calculate the A here? No need, because it is asking the area of the shaded region, right? So for the answer, it's just the shaded. The shaded, we have already know it is 4A squared, right? 2A times 2A. The sign is 2A. So here, shaded 4A squared, it will be equal to 4 times A squared, and we know A squared is 40. So 4 times 40 will give you 160. Yeah, so we know it is 60. We don't need to get the A here. Okay, so this is question 27. So any questions for the first 27 questions? Okay, so no, then I just continue. Dead. Okay, but for the last questions, I think it is not that hard as the previous one. Right. The TASMO sample paper 1 is really hard, but for the TASMO sample paper 2, I think it's not that hard. Alright, question 28. Yeah, we have a 6-digit number having the property 1, 2, 3. So the first property, the same as reading backwards. So we can just know it is A, B, C, C, B, A, right? From property 1. It will be like A, B, C, C, B, A. And from property 2, multiple of 8. So it means the CBA here is a multiple of 8. Right, it's a divisibility rule. And for property 3, so when we first remove the first number and the last number, yeah, ABCCBA, we remove the first digit and the last digit, it will become BCCB. Yeah, it has only one prime factor. This is all the things we know. So which one should we start? A, B, C, C, D, we have so many combinations. Multiple of 8, we have so many combinations. So we can only start with the property 3 here, right? Only one prime factor. It's super easy, right? And it is super important. So B, C, C, B, one prime factor. Can we just do the prime factorization? No, because we don't know B and C. But we can know something about it, because we can use the place value principle, right? 1000th digit and 1st digit is B, and 10th digit, 100th digit is C. Yeah, we have something interesting in the digits here, so we can use the place value principle. So BCCB, we know it is thousands, we have B, so 1000B. Hundreds, we have C, so 100C, and tens C on tens and B on the 1st digit. So we know it is 1001B plus 110C. So here, 1001 it is 7 times 11 times 13, right? So here, 7 times 11 times 13B, it is 110, 11 times 10C here, right? So among it, do we have one prime number which appears in both terms? Yes, we have 11 here. We have 11 here. So we can extract the 11 out. So it is 11 times 7 times 13 times B plus 10C here, right? So we know this one is like BCCB, and it has only one prime factor, right? BCCB it is 11 times something. So the one prime factor, it can only be 11, right? Because we have already got 11 here. No matter what it is 11 times something, and 11 is a prime number, a prime factor here. So the one prime factor can only be 11. So we know this part, it is also having only one prime factor, which is 11, right? So we know this one can only be composed with 11. So it can be either 11 square or 11 cube. So let's think about it, right? So the things inside the bracket, it is 7 times 13 times B. Yes, we have 91B. And plus 10C. Of course, B cannot be 0, right? B cannot be 0. So here, yes, we just make it as the 91B plus 10C, right? It is larger than 11, right? So if B is 0, 0, right? So we just need to make C as 0, but they have different numbers, right? So here, 91B plus 10C, larger than 11. But is it larger than 11 cube? Which is 1331. So for the 11 cube, we need to think about the largest principle, right? The largest situation. So B here is 9, C here is 9. Of course, it is smaller than 11 cube. So no. So we know 91B plus 10C here, it is 11 square, right? We know it is 11 square. So it will be 1 to 1. B here, it is 1. C here is 3, right? We know this part. And then we can make it into the property 2. The CBA will become 31A, which is a multiple of 8. So among 310 to 319, only 312 is a multiple of 8. 8 times 39, right? So A here is 2. So number ABCCBA will be 213312, right? This is number 213312. So now we can know the answer, right? The answer is asking the number divided by 24. 213312 divided by the 24 here, right? The answer will be 8888. Yes, so the answer for the question 28 is 8888. A quite lucky number here. Alright, the question 29. Yeah, question 29 is a question from the MOS, the Sierpinski triangle. Yeah, but although we have some some difficult shapes, the question is not that hard. It's about finding the pattern. Because, yes, you can see stage 0, stage 1, stage 2, stage 3, it is the pattern here. So we can also find the pattern for the number of black triangles and white triangles. So yeah, we have the black triangle, we have the white triangle, and we have the stage. For stage 0, 1 black, 0 white. For stage 1, 3 black and 1 white. For stage 2, we have 9 black and 4 white. For stage 3, you just count. We have 1, 2, 3, yes, 9 times 3, 27. And we have how many whites? 13 whites. So based on it, you can just find the relationship, find the pattern here. Right? We have 4, 5, 6, 7. So for the black triangle, yes, every one black in the next stage will be divided into 3 parts. Right? So we just times 3. This one times 3. This one times 3. So the fourth, 27 times 3, 81. For the fifth, 2, 4, 3. For the sixth, 7, 2, 9. For the seventh, it is what? 7, 2, 9, we times the 3, it is 2187. Yeah, 2187. And for the white triangles, you can see, yes, every black triangle will generate 1, right? And there is 1 white in the middle, right? No, there is 1 white in the middle. Or you can just find the pattern here. 0 to 1, 1 to 4, 4 to 13. Yes, we times 3 plus 1. This one we times 3 plus 1. This one we times 3 plus 1. So for the fourth here, 13 times 3 plus 1, 40. 40 times 3 plus 1, 1 to 1. 1 to 1 times 3 plus 1, 364. Right. 364 times 3 plus 1, 1093. Right, we know it. So we know the stage 7, right? We have 2187 black triangles and 1093 white triangles. So the answer here for the B minus W, it is 2187 minus 1093. Right. 2187 minus 1093. So it is 1094. This is the final answer. Alright. Okay, finally we come to the last question. So printing numbers on a banner, we have digit 137, digit 2 to 90275, and multi-digits. Okay, we want to find all the possible. So although it is the last question, but I don't think it is quite hard, right? You just need to list all the possible answers, right? You just try. So we can just divide it into the different number with different digits. So here, we can think about first, the 1-digit number. Right. If it is 1 here, we have 37. So 37 is of course larger than a 1-digit number, right? Larger than 9. No. How about the 2 to 9 and 0? 75 cm here. Of course larger than 9. So no. So for 1-digit number, 0 number being possible. Right? How about the 2-digit? For 2-digit, we have several cases. The first, it is 00. But is 00 being possible? No. Or we have 1-digit 1 and the other digit from 2 to 9 or 0. So it is 37 plus 75. Also larger than 99, right? So it cannot be a 2-digit number. No. So how about we have 11 here. 11 here is 37 plus 37, 74, right? It is. But we have 1 and 1. Is 74 equal to the combination of 1 and 1? No, 74 is combination of 4 and 7. The element is not 1 and 1 here. So also no. So here, the 2-digit sum, 2-digit number, also no numbers being possible. So now let's think about the 3-digit number. 3-digit number also have several cases. The first case is we have 1, we have 1, we have 1, right? So the total length here is 37 plus 37 plus 37. It is 1, 1, 1. The elements here 1, 1, and 1. We have 1, 1, 2, 1, 3, 1. 1, 1, 2, 1, 3, 1. Yes, it will be the case. right? We have 1, 1, 1 being one possible number. And how about we have 1, 1, not 1, 1. How about we have 2, 1 and one number not 1 here? So 2, 1 here, 37, 37. And the number not 1, 75. So if you add them up, it is 149, right? We have 1, 1, 2, 1. But the elements should be 1, 4, 9. We only have 1, 1 here. 2, 1, 2, 1, 1. It cannot be the case. So, no. Right. So, how about the third case? We have only 1, 1 here and two numbers not being 1. So, 37 plus 75 plus 75. So, the answer here is 187. The element for the number is 1, 8, and 7. So here we have 1, 1 giving you 37 in length, and then yes, we only have 1. So 187, the length for it is 37 plus 75 plus 75, also 187. So this would be the case, right? 187. And then how about the last? Every number is not 1. So 75 plus 75 plus 75, it is 225. Yes, we have 225. No 1 being here. Can. Right, 225. So 225, 75, 75, 75. The total length, 225 also. Right, we have 3 numbers here. So how about the 4-digit number? So the maximum in length is 75 we times 4, right? But it's also smaller than the smallest 4-digit number, 1000. So of course, no. 5-digit, of course not. 6-digit, of course not. Right? The length will always be smaller than it. So 0 number here. So we can just list. Yes, we have 111, 187, and 225 being the correct answer. So the final answer is just 111 plus 187 plus 225. Right? So it will be 523. Right? It will be 523. So here 523 will be our final answer. Okay, so this is how we just solve all the questions in this paper. So do you have any problems? If you can just tell me. If you don't have, then we should have a good day. Okay, then if you don't have, then bye bye everyone. So I will see you in the next long-term class or the next live session. Right? Are all the answers in TASMO whole numbers? Yes, all the answers in TASMO will be whole numbers. Yeah, if no, then I end here. Yeah, bye bye everyone.